Hi everyone, welcome back to the channel. Today we are shifting gears a bit to talk about data warehouse in Microsoft Fabric. So, what is actually a data warehouse? Data warehouse it's a relational database, but it's optimized specifically for analytical workload rather than transactional processing. That is the key difference. In a regular transactional database, you are constantly inserting, updating, and deleting individual records. Think of an e-commerce system updating inventory or an airline booking systems. Those databases are designed for fast individual transactions. A data warehouse, on the other hand, is designed for querying large amounts of data, often aggregating and joining across multiple tables. Normally or usually you don't update it in individual records. Instead, you are loading batches of data periodically and then running complex queries to analyze trend, calculate metrics, and generate reports. So, what makes Fabric's data warehouse special is full SQL semantics. Unlike the read-only SQL endpoint you get with a lakehouse, a Fabric data warehouse gives you complete control. You can create tables, insert data, update records, even delete if needed. It's a full-fledged database that just happens to be optimized for analytical queries. Now let's talk about how data warehouses are typically structured. Most data warehouses follow what's called a star schema or snowflake schema. And these are built around two types of tables, fact tables and dimensions tables. Fact table contains measurement of metrics you want to analyze. Think in a sales scenario. Fact table might have columns like sales amount, quantity sold, tax amount, unit price. And these are the numbers you want to add up, average, and analyze. On the other hand, dimensions tables contain the descriptive attributes that gives context to those metrics. Who was the customer? What product was sold? When did the sale occur? Each of these who, what, when, where questions is typically answered by a dimension table. So then this structure is powerful. Why? Imagine you know who like total sales by customer by month. Fact table has the sales amount. Your customer dimensions has the customer names and details. Date dimensions has information about dates, including which month they fall into. And by joining all these two tables together, you can slice and dice your sales data in countless ways. The relationship is typically many to one. That means many sales transactions might relate to one customer, or many sales might occur on a single date or day. This relationship create a star pattern, which you visualize them. When you actually visualize them, it is called a star schema. Now let's talk about data models. In Microsoft Fabric, you can define this relationship explicitly in something called a data model. This is really important because it makes querying much more intuitive and it supports virtual like visualizations. When you create relationship between tables, you are telling the system how they connect. You specify the cardinality, like many to many, many to one, one to many. Now, here is something interesting about data warehouse. In traditional transaction databases, you would typically enforce foreign key constraint to maintain data integrity. But in data warehouse, these constraints are often not enforced. Why? Because enforcing them adds overhead during data loading. And in a warehouse, data quality is typically ensured during ETL process before data even arrives there. So you define the relationship for query optimization, and to help tools understand your data structure, but you might not enforce them with actual database constraints. It's trades-off between data integrity guarantees and load performance. In most cases, for analytical workloads, these trades-off make sense because you prioritize query speed and load efficiently. So once your warehouse is structured with facts and dimensions, querying become very natural. You typically writing SQL that joins tables and aggregate data across dimensions. What's powerful is how you can easily and um, add more dimensions to your analysis. The star schemas makes this kind of multi-dimensional analysis straightforward, and you are not limited to just aggregating. You can create more complex analytic queries using window functions, common table expressions, case statements to categorize data. SQL in a data warehouse gives you tremendous flexibility, and you can create also views and visualization, because this is why your warehouse really becomes useful for end users. So a view is essentially a saved query. Maybe you have a complex SQL statements that joins multiple tables, perform calculations, and structure the data in a particular way. Instead of writing that query every time, you can save it as a view. So then user can just query the view and they can get the results without needing to understand the underlying complexity. But there is something more. Like when you create visual queries without writing any SQL in Fabric, using a graphical query designer, you just drag tables onto a canvas, define joins by clicking, and build transformations visually. It's like a Power Query. And for users who are not comfortable with SQL, it's incredibly powerful. And of course, visualizations. Once your data is in the warehouse, you can connect it directly to Power BI. You can hide technical columns that users do not need to see. You can create relationship in the semantic model and then build interactive reports with charts and tables. The warehouse provides the data foundations, and Power BI makes it accessible and actionable for decision making. Now, let's go through the lab uh, for getting a clear picture and clear understanding. Let's start the lab now. In this lab, we are going to do create analyze data in data warehouse. So let's start the lab. In this lab, we'll go through analyze data in a data warehouse. So in Microsoft Fabric, a data warehouse provides a relational database for large-scale analytics. Unlike the default read-only SQL endpoints for tables defined in Lakehouse, a data warehouse provides a full SQL semantics, including the ability to insert, update, and delete data in the tables. So very first thing we need to do here, I have already connected to Microsoft Fabric. So we have to create a workspace. Click on workspace. And under advanced, that licensing option, you will see, make sure that Fabric capacity is enabled. Click on apply. Got it. So now this workspace is empty. Now we are going to create a data warehouse. For that, under workspace, click on new item, and you can just um, quickly search warehouse. So click on, we are going to use just create a new data warehouse section. So click on warehouse. So give your warehouse name, click create. So it's creating a new warehouse. So now it's empty now. Now we are going to, it's a like warehouse is a relational database in which we can define tables and other objects. So now in this warehouse, we are going to create table. So for that one, select on T-SQL tile and execute SQL like we are creating table under DB schema dim product, and under the table this will be columns name. So let's execute that one. So you can check here before and here under this schema it is going to create that table. So let's execute that one. So when that is done, we can see the dim product table has been created. Now we are going to like create a new SQL query window. So we can do that from here. So new SQL query, it will open another tab. Click that one, and we are going to insert some data. Now like that table, we are creating inserting 3 rows. Now when that is done, if we select here this table dim product, we can see that 3 rows has been added to that table. So let's open another SQL query session. Let's open this transact query that we're going to use. So get the text here. Let's copy this one and paste it here. So if we check the syntax, it's actually going to create a few tables like dim product. We know that it's already there. So in that case, ultimately it will drop the table and create a new one and then insert some values. And then it's going to few more other tables also, dim customer, inserting values, dim date. So let's execute this one. So it's running. You can see the progress from here. That's running or it failed. If you want, you can also cancel from there. And there is also explain query, which will give you like what it is doing. So now here you see that uh, 4 tables like dim customer, dim date, dim product, fact, sales order has been created. Now let's query the data warehouse tables. So for that, let's open another SQL query session tab, not session. So here, let's execute some query. So we are selecting year, month, month of the year and month name, and sums of sales revenue uh, from fact sales order table, and joining with um, dim date based on sales order date key. So from fact sales order, this key which is SO is alias, and date key from D another alias. So which is dim date. So this is a alias for this table. SO is alias for fact sales order table. So we are just giving relationship here and then group by and order by clause. So this is something we are just executing some query to see the different data warehouse operations. Let's execute some more SQLs. Sometimes that way it is better to open separate SQL session. So this time we are doing like sales revenue aggregate based on like year, month, and also sales region that we are trying to get the output. Open another tab. And sometimes you can create a separate SQLs like uh, what I actually doing. So this is the output that we get last time. So what we are going to do, we are going to create a view based on that data. So we do not need to write this big SQL. We can just query that table, it will give us value. So if we do that one, so view has been created, query succeeded. So if we just select from here, so we do not need to write that SQL, big SQL that we are doing. So view is sometimes good that based on your specific requirements, you can just create a view and query the data. And you can see that the view we created, you can get that from here also, that sales by region. And let's do a few more SQL here. So from there, we can just even select a specific one. So we are using view, from view information. So now let's do some, like we have so far we have used SQL code. Now we would like to use a graphical query designer to query the tables in your data warehouse. So this is something similar to Power Query Online, where you can create data transformation steps with no code thing. So for that, here under SQL, select that new visual query and drag the fact sales order into this canvas. And you can see the preview of the data down below. And now drag the dim product. I'm going to make some relationships, so therefore I'm just doing that one. So now we'll see the data from this dim product. So we have got two tables. So now here let's select that plus button, and there are different operations here. So for now we are going to use that um, merge queries, and in the merge queries windows we'll select the this table fact sales order is going with the dim product table. And for merge operation, we are going to use product key from fact sales order and product key from dim product. So now you can see there are different join tabs you can select. Here left outer join is fine for this lab perspective, and click on OK. And this is all, you need to do some study. If you're from database background, then it's very easy if you know that one, because it will take time, so I'm not explaining all these here. So there are different types of joins you can use. So click on OK. So now here you can see that in preview section, a dim product column has been added, uh, that we can see, like fact sales order, there is a new column dim product, and let's click this button to explain that one, and you can see all are there. So from here, deselect all, only select that product name, click on OK. So if we are interested to looking at a data for a single product, uh, for a manager request, you can now use this thing like product name column to filter the data in the query. So from here we can like analyze the results of the single query by selecting this or this edge option that we can see. You can visualize results. So in our case, not much data there, therefore we cannot see that one. But you definitely, like if you have data, then you can select the different option like chart option, and then you can save as a report. Let's cancel this one. Also, there is an option like you can download that Excel file like this, and you can see the information. You can also save as table, so that will be save some table name. If you do that on, like if I say test 01, under the DBO schema, you can see that there will be one table test 01. So it's creating. So there are different options that you can do from here. You don't need to write any code. Now let's do like define a data model. So for that, in this toolbar section, you see that new semantic model. Select that new semantic model. Now here, give a semantic model name. Select the workspace. And then select all the 4 tables. This is my test table, so not that one. Those 4 tables, and click on confirm. So that has been done, but I cannot see that it came up here. So let's go back to workspace. And here you see that semantic model. Select that one. And here open semantic model. So just collapse that one to see the full thing. This is now view mode. Go into edit mode. So it's converting semantic model. I think that's going back to like edit mode. Close that one. Now let's make a relation from this fact sales order, that product key, with the product key of dim product. So let's drag that on. So it will open a new relationship page. So here is that fact sales order product key and product dim product key. Cardinality is many to one. Cross filter direction is a single direction. And make this relationship is active, that is selected, and referential integrity, that is deselected here. Take the default, select save. Now from product key, a field from the pack sales order table, and drop it into the product key field in the dim product table. Or currently it has got into viewing format, so make it into editing mode. So now let's drag product key field from the fact sales order table and drop it into the product key field of dim product table. Then here confirm the relationship details. Make sure that it has got the right key and right table. Um, uh, Product key of dim product table. Then cardinality single cross and click on save. And let's repeat the process to create many to one relationship between customer key from fact sales order to customer key of dim customer. Make sure that one, that table name, column name, table name, column name, cardinality many to one, cross filter discussion single direction, and click save. Now little bit drag down, dim date, and here you can see also manage relationship. So from there we can also see the relationship status. A new relationship. This time we are going to do sales order date key from fact sales order. So we can do this way also, like select from there, and then to table is dim date table, and key is date key, and cardinality is many to one, cross filter direction is single direction. Click on save. So we can see that relationship here. All the relationship has been defined. So you can do define yourself if you want more based on the requirement. So there's option like you can delete that on relationship or you can edit the relationship. So model should be look like this. So we have successfully completed our lab. Now let's clean up the workspace. So from workspace setting, click the workspace down below and remove this workspace. That's all for this lab. See you in next lab.